Hey, what's going on, everybody? Today's kind of mini lessons looking at aquatic ecosystems. We're going to kind of set the stage for all aquatic ecosystems, and then we're going to just talk today about freshwater ecosystems. The next lesson will be saltwater ecosystems. So let's get into it. Obviously, there's many different types of aquatic ecosystems, right? You can think of the oceans, you can think of rivers and lakes and streams, but we also have to include different types of wetlands, such as this swamp right here. We also got to include, which could be a marsh here, and then difference between like lakes and rivers and streams in terms of standing versus flowing water. But whenever we talk about ecosystems, we really talk about some key characteristics. We focus on water salinity. Obviously, ocean saltwater, freshwater is not saltwater, but there's all different variations and levels of salinity in terms of aquatic ecosystems. You can kind of think of brackish water as the connection between, a river flowing into the ocean, where you get kind of varying levels of salinity as you move further up a river from the ocean. Depth obviously plays a big role. Temperature, right? Plays a major role. Standing versus moving water, so flowing versus standing water. And then also the big one here is nutrient availability. So when we focus on nutrient availability, is how many nutrients or what concentration of nutrients are available in that ecosystem. So if you think about such as a saltwater marsh, like you get out towards like where the meadowlands are, right? When you're driving by the meadowlands in a saltwater marsh at low tide, it kind of smells bad. You ever notice that if you drive by a marsh, it smells bad? Yeah, it smells bad. It's because there's a lot of decay there. There's a lot of nutrients that's being decayed, but that's not necessarily a bad thing. That's a good thing because those nutrients are available for plant growth, right? Marshes, wetlands like that are actually great places of biodiversity because there are so many nutrients there available for organisms. Okay. We'll start with water depth real quick. When we look at water depth, we focus on layers we call the photic zone, right? And we call it the aphotic zone. The photic zone is where you have light. Right. So when we go swimming in the ocean or swimming in a pool, you're swimming in the photic zone because there's light available there.
When it's dark.
Right. When it's dark, you're in the aphotic zone. Yeah. So if you keep going down deep, you get down to about 200 meters deep, which is 650 feet deep. You ever been that deep? No. Okay. That's where you shift from the photic zone to the aphotic zone. And obviously that's going to be a shift in the organisms that live there. Those numbers are kind of fudged a little bit because it depends on where you are, right? The clarity of the water plays a role with the depth of the photic and aphotic zone. So that's just kind of an average in the ocean, kind of like the open ocean is what we're looking at.
You're in a subway deep down.
Yeah, subway, but we're focused on water though. So subways can go underwater, but it's a little bit different, right? As it goes like under the Hudson River with the path or something like that. So the photic zone is where you find most organisms, right? Because most organisms rely on light. There's going to be algae growing there. There's going to be plants growing there. Where you have producers, you have the basis of an ecosystem. As you go deeper down, you can kind of move into the aphotic zone, where organisms can either travel in and out of the aphotic zone, such as like whales, like a sperm whale could travel deep down into the aphotic zone to grab like a large giant squid, and then kind of move back up. But you also have some organisms that kind of live in the aphotic zone. Turtles mainly photic zone. They kind of live at the top, but you can kind of think of like anglerfish. You ever seen those fish that have like the weird light in front of them? Yeah. So there's like weird, crazy kind of fish that live, or creatures that live down in the aphotic zone. And obviously they got to get their food from something. So they're eating fish that live down there. There's a lot of detritus debris that kind of falls down, almost kind of like snowing. Like what?
X-ray fish?
X-ray fish can live down there, yeah. There's a lot of detritus debris that can kind of flow down that can, really support ecosystems down there. And then you also can have, chemosynthetic bacteria as well that can play a role. If you go all the way down the aphotic zone, you go always down to the bottom of the ocean, like the very bottom of the ocean. That's known as the benthic zone. So the benthos are bottom-dwelling organisms. But the benthic zone goes from coast to coast. So if you walk in the ocean and you're walking, kind of like your feet are on the benthic zone, but it keeps going down, deeper and deeper and deeper as you walk further out into the ocean. So it's really kind of focused on depth there. With freshwater ecosystems, we have two major types. We have standing water ponds and lakes, right? Standing water meaning the water kind of like stays there. There's not a ton of flow. There's always going to be a little bit of flow, but not a ton. And then we have flowing water, like rivers and streams are flowing water. And then typically at the edges of these freshwater ecosystems, or saltwater as well, but freshwater is what we're focused on. We have wetlands. All right, there's some wetlands shown here in terms of like a marsh, which is a flooded grassland. Okay. So freshwater wetlands are simply areas of land that are flooded with water at least part of the year. So it doesn't mean they have to be covered all the time, but they're at least part of the time that they're covered with water. And typically you get this at the edge of rivers and lakes and streams. And there's 4 key types of wetlands. We have our swamps, which are essentially flooded forests, right? Mm-hmm. Like slow moving water, like it's almost like a very, very slow moving river that kind of keeps that forest flooded for most of the year, if not the whole year. Marshes? Yeah, a marsh is kind of what you see at the edge of a river. So like when you're going out to the Meadowlands, you're going out to the beach, right? Mm-hmm. You see marshes all the time on either side, right? You've been on a boat out there, right? Mm-hmm. With your cousin? Yeah. You have a fen, which is a little bit weird and a little bit different. It kind of falls in the similar category as a bog right here. So bogs and fens aren't really so much attached directly to rivers and streams. They're a little bit more separated. I'll talk about a bog first. A bog, obviously, like peat moss is a key aspect of bogs. You think of bogs when you think of like Scotland and Northern Ireland. It's really kind of a valley that's a flooded valley. The water sits. It's not really attached to any type of, what's that? Flamingos are going to live more in kind of a marsh, like a mangrove swamp or a marsh. Some do. Yeah, not really in bogs. There's not many flamingos in Scotland. They're more warmer weather. But in any case, so here we have our bogs, which are really kind of flooded valleys in a sense. So the water's there. There's a lot of peat moss. The water tends to be fairly acidic, and it kind of stands for most of the year, if not the entire year.
What are those animals in the bogs?
What's that?
What are those animals in the bogs?
I don't know what those are. Those could be like different deer or sheep. No, those are just birds. Those look like geese. Yeah, it looks like a geese there. Tough to tell because it's small. A fen is similar to a bog, but you get a little bit more water flow. There's a little bit more of a connection between like rivers and streams. So they're similar. Still peat moss, very acidic soil. It's kind of just like a flooded low-lying land, but there's a little bit more of a connection to some water movement, where bogs are pretty much isolated from rivers and streams for the most part. When we talk about all these wetlands, they're very, very important to kind of preserving, our ecosystems, our coastal ecosystems. Wetlands are the best filtration systems we have going. Water can be filtered going back into the ocean, kind of filter out a lot of those salts, and vice versa. A lot of toxins, a lot of chemicals can be filtered out of runoff coming from the land before it gets into the ocean. So marshes are critical to kind of really filtering and cleaning and preserving our coastlines. And that's why there's an issue. Like if you look at, especially like the Jersey Shore or Florida, like we're developing wetlands like crazy. So there's less and less wetlands. We have less and less wetlands. We're more prone to flooding because you don't have that wetland protection, more prone to pollutants getting into the water because you don't have that filtration system. So really when you kind of destroy a wetland, you're really harming, the entire environment that surrounds it. And that's it for the day. Tomorrow we're going to talk about oceans, saltwater ecosystems.